All right, welcome back. So now we're moving on to our new section, and that topic essentially continues building off of what we've done. So, in other words, this section keeps building on the fact that we know how samples behave. So we've got the sampling distribution. And from that, the first thing that we saw was that that information allows me to create confidence intervals. So hypothesis testing is a variant of confidence intervals because confidence intervals, if you recall, allow you to make a statement about the parameter, the population parameter, whether it's mu, p, or sigma. And if you have a pretty good idea of what the population parameter is, you're also doing a hypothesis test because what's going to happen now is we're simply going to go ahead and formalize everything. Hypothesis testing is essentially what we do intuitively every day when we are faced with a claim or story that is just so unbelievable that we need to ask, wait, did this really happen? Because what you're essentially doing is you're realizing that the story or whatever someone's talking about is very extreme, very unusual. You don't think it actually happened. And that's basically what's going to happen here. So it's exactly the same commands, same notation that we've looked at before, but hypothesis testing is essentially a formal procedure. So when I say formal, think of when you go to a formal dance. It's still a dance. It's just, there's a dress code and you have to look a certain way. And that's basically what a hypothesis test is. It's just a way to formalize everything that we've been doing. So let's go ahead and take a look at our first example, and it'll introduce a lot of the terminology and just different structure that will be pretty much with us for the rest of the course. All right, so filling a drink or really anything. So anytime you're a business and you're selling some kind of product, so think of a product. In this case, I'm thinking of a drink. And if you're selling this product, it's really important for you to describe it accurately. So most recently, Subway was sued because their footlongs were not actually a foot long. And so now, I'm not sure how many of you have noticed this, but if you go to any Subway now, there's a actual like metal ruler next to it, so that every sub is checked for agreement with that claim that the foot long is actually a foot long sub. All right, so here we're looking at coffee. So from Starbucks, this is a latte. I searched the web and just to make sure everybody knows what it is that we're talking about here. And in 2016, plaintiffs, so I had their name in there, but I realized we might not want to make them infamous. But anyway, plaintiffs sued Starbucks in a class action lawsuit. So basically trying to represent everyone that was affected because they claimed that Starbucks knowingly underfilled lattes by around 25%, alleging that the cups used to serve the drinks were not large enough to contain the volume claimed on their menu boards. They also had this pretty interesting line here. So if you've ever seen how the coffee's made, you know that as it's being processed, there are these fill lines in, for example, the pitcher or blender that the barista uses. And what they said is that the fill line on the milk pitchers used by the barista didn't measure up to 12 ounces for tall drinks, 16 ounces for grander beverages, and 28 ounces for venti. So if you've ever gone to Starbucks, if you're a fan, you know that that's their sizes, right? So small, medium, large, and they just came up with creative ways. So what we're going to focus on is we're going to focus on the 16-ounce drink for this example. But I just want you to know that all is well. Starbucks actually said that, yeah, when I fill something up to the fill line, it's not going to measure 16 ounces. It's going to measure less because a latte has milk. So a latte is basically milk that is steamed. So you heat it up. And if you've ever cooked anything with milk, you know that the milk actually foams up. and expands. So that's what Starbucks said. Luckily, this suit was actually thrown out. You can click this link here and read the not a report, but just read more about this case. That's where I got these quotes from. And so now that we know how serious this is, we want to make sure that when you get a latte, right, it needs to have this be as close as possible to this advertised amount. The judge eventually did say that the foam is part of the drink. And any reasonable person that buys a latte knows that the foam is part of the drink. So this stuff up here, that counts as part of the drink. If you've ever ordered a latte, you know that if you wait too long, the cup kind of seems empty. All of this is gone. And that has to do because a large portion of that foam has essentially dissipated back into liquid form. This makes it clear why people were alleging that Starbucks is underfilling cups. So let's go ahead and start with our with our example. So we've just read that a Starbucks, medium is a 16-ounce cup known as a grande, and it's supposed to have 16 ounces of my beverage. So whatever beverage that is, whether it be coffee, refresher, apparently latte, right? It should have 16 ounces. And this is more or less the way that the world works, right? You go in to purchase something and there's an advertised claim on the components, on the lifetime of the device. And so the world works by giving all these claims, right? We're trying to describe products around us as best as possible. So here, this is the claim that the Starbucks Grande has 16 ounces of beverage. However, if you end up going to Starbucks, right, like this plaintiff, and then you start to feel like there's just too much empty space in your cup. So maybe you open it, you're going to put some sugar in it, and you realize, whoa, this is super underfilled. And so you really start to ask yourself, is the average amount of ounces in the cup actually 16, or is it different? And again, there's too much empty space. So you already have a feeling of what could happen. So this is essentially going to be a hypothesis that I'm going to walk you through. Just kind of look out for some of the main components that we'll be using in our next video. So the claim is that the Starbucks Grande has 16 ounces of coffee. So notice that coffee, the number of ounces in coffee, is a quantitative variable. Because it's quantitative, I'm not going to be interested in, proportion, right? I'm going to be interested in either the mean or the standard deviation. So you need to first make up your mind. Like, what is it that you're trying to describe here? This claim that Starbucks, 16 ounces are in a grande, what is that with respect to? Well, it's with respect to mu, right? The true average number of ounces in a grande cup. They're not interested in variability. They're just saying this is how much is supposed to be in that cup. So they're summarizing all of the actual values into one value. And they're telling us that it's 16. So that's my population parameter, mu. And I've noticed that Starbucks has given me a claim. So the claim comes from Starbucks. And we're going to go ahead and write this out as H0. H stands for hypothesis, 0 because it's our starting point for our hypothesis. It's a lot of times it's called H0 or H0. So the claim is going to be the following. So my starting claim is that Starbucks tells me that mu should be 16. Okay, and so again, if you go to any product, you're going to be able to look at all kinds of claims that are being made about that product, whether it be the calorie level, right, amount of sugar, any kind of quantity that is quantitative. And that's given to us by the company. So this should be clear. We are able to write this. Okay, the claim is that there's 16 ounces. Now, again, after looking at enough cups, right, you go to Starbucks enough and you realize, something doesn't quite feel right because there's too much empty space in my cups. So this already gives you a feeling, right? You think that something is up. So this is going to be your belief. Now, your belief is going to be denoted as H1 or HA for alternative. And you're basically going to go ahead and say mu and 16. Now, your belief is going to fill in this empty circle here in the middle. So what do you think is true? Starbucks says that the mean is 16. But again, we don't feel that that's true. We actually feel that there's too much empty space, which means that we don't think there really is 16 ounces on average. We think that this is smaller. So what we think is true, and again, that's because there's too much empty space, is that mu is in fact less than 16. That's what we believe. And again, this is always what you are trying to show. We think that this is true. So again, we're going to go, now that you've set this up, you can say, okay, for sure you need a sample. We're going to go ahead and say, okay, if I were to take a sample, what should I observe? So here's my first sample, X1, second sample, third sample, and notice how 15.94, 15.74, 15.21, 15.36. So they're all under 16, but is that evidence to say that the average of all of the cups is under 16? Okay, so anyway, we take 16. It should be random, right? It shouldn't be at that same store. This should be a random sample of all drinks. And you can see how demanding this would actually be to collect. But anyway, we've got 16. And now the question becomes, how do we combine our knowledge of sampling distribution, confidence intervals, to essentially help answer this question? And in the previous chapter, you know that you can make a confidence interval. So that's one thing you could do. What I want to do is I want to show you how the sampling distribution kicks in. And I always want you to draw this. So the sampling distribution is going to kick in. And we're basically going to say, when I take a sample of size 12 is too small. And this is regarding mu. Again, we don't know what mu is. So mu is unknown. And so is sigma, right? The population standard deviation. So therefore, we're going to say when I take samples, I know that the sample statistic from chapter 8, that it has a very predictable behavior. The distribution that I end up with, assuming, the normality conditions, so assume the requirements are met, then we're going to go ahead and write the degrees of freedom right here. So that's n-1. And then we're going to say this is how samples should behave. So the middle here should be 16, right? We're essentially going to say, let's pretend that this is true. I'm not going to argue. I'm just going to say, okay, let's say for the sake of argument that Starbucks is correct. Then my sampling distribution will be centered. This guy right here will be 16. Now, when I take an actual sample, I don't expect to land right at 16. I know just by random variability that I could end up maybe over here, or over here, or over here, or here. And so if we take a sample, it's way more likely that we will actually end up very close to the middle. It's very unlikely that we're going to land very far away from the middle. And that's what we did in chapter 8. We said, yes, we know this. So how does that help us? Well, here's how it helps us. Remember, the hypothesis test is a formality at this point. What we're going to say is well, I believe that the mean is less than 16. So I'm calling this ahead of time before I collect my sample. I'm saying, I am pretty sure that Starbucks is wrong. And I believe that we're going to get a sample mean less than 16. So if we are trying to get us mean less than 16, we're already saying we're not going to land here in the middle. We're going to land to the left, like unusually far off to the left. So we're essentially saying ahead of time that we believe when we take a sample, we're going to land here to the left-hand side. And again, that comes from my belief as to what's going to happen. So I believe that that's what's going to happen. In order for you to have convincing evidence, so your sample will essentially say, okay, let's take a sample and let's finally see what is going on. So if we land in this tail, then this is evidence to support your claim. You're basically saying, I told you that the average was going to be less than, like, way under 16, which again should not occur if Starbucks is correct and the true mean is 16. But if the true mean is less than 16, then we expect to land significantly further off to the left on this distribution. And that's pretty much what's going to happen. This is going to be called a critical region. And we've already found this. This is with tails. So this is going to be called T alpha because the area out here is going to be alpha. We're essentially saying how unusual do we got to be. So a standard value for alpha is 0.05. We've seen this before. And if you were given an actual, oh, and we are actually, we're given an actual sample size. So we know the degrees of freedom here is 11. So I can actually find the quote unquote number of standard deviations that I can go to the left before I actually do get a sample that's way too far off to the left. So let's actually go ahead and find this. Remember that whenever you draw this, a graphic like this and you've got stuff labeled, you can always find anything that's missing. So I'm going to go to StatCrunch and go to stats, T-stats, oh, sorry, calc, T. Degrees of freedom was 11. And I'm saying I want to land to the left with an area of 0.05. So notice this is the graphic that I have on my paper, right? And so the area is 0.05. Remember, area is always after the equal sign. And we get our critical value, negative 1.796. All right, so all of this gets done before you actually take your sample. You're saying, okay, now let's see where our sample lands. So now comes the moment of truth where you're going to say, okay, finally, somebody has put in a lot of work to collect these sample here. And now we're basically going to say, where does that sample land on this distribution? Does it land in the red region? In other words, supporting my claim that, yeah, I knew we were going to get a mean that's very small. Or are we going to land in the non-red region? So that would be non-critical. And remember, if you land here, then that's not unusual at all because that's what Starbucks was saying all along. In this distribution, we're going to land somewhere here nearby. And that's more or less how we will perform this test. So the next question becomes, how do we determine this? And so we're going to determine this by doing or by finding what's called a test statistic. And the test statistic is essentially the statistic that we've been making, the statistic that we've made all along. So the formula for it is T is equal to X bar minus mu. So remember, X bar is my sample mean. Mu is this guy right here. We're saying it's 16. Divided by S, the sample standard deviation, over square root of N. So I'm not sure if you recognize this. It's basically the quote-unquote number of standard deviations when we replace sigma by S. And so we saw this in the previous chapter. Luckily for us, we don't actually have to do this by hand. We have StatCrunch. So let me just go ahead and show you how we can use StatCrunch to get this number. And then I'm going to go ahead and draw it in this figure. Okay, but notice that we essentially will always have two hypotheses, something that's claimed, something that we believe is true. You will always sketch the distribution that's relevant for your parameter, and you're going to label this region here. And then let's take a look at our sample. So to compute the test statistic, you're going to go to stats, or really for anything in this chapter, you're going to go to stats, and then select the appropriate command. The commands are the same from the previous chapter. So remember, this is a mean. So I'm going to be going to stats, T-stats, because it's a mean. Proportions would be proportion stats, and variance would be variance stats. So in this case, for my mean, I'm going to go to tstat, one sample with data, because I've got the actual data on my table. I'm going to select my data. And then if I scroll down, you're going to recognize this from the previous chapter when we would find confidence interval. So we could definitely do this. But what we're doing is called a hypothesis test. And what we need to do is we need to make sure that this matches. So the original claim is that the mean is 16. Now, the alternative, you need to go ahead and change the sign here. What do you believe to be true? I believe that the mean is actually less than 16. And believe it or not, that's all we need to do. We press compute. StatCrunch summarizes the hypothesis here, and StatCrunch gets to work. And it finds all of those quantities that we needed. So here's X bar. Remember, the standard error is S over square root of N. It's basically sigma of X bar when sigma gets replaced with S. Degrees of freedom. So that's N minus 1. And finally, here is your test statistic. This test statistic is literally X bar minus mu, that's claimed right here, over S over square root of N. We don't need those formulas because we're not going to be using those formulas. We're going to be doing this with StatCrunch. And so what I'm going to do now is I'm going to sketch that on my distribution. All right, so what just happened? We took our sample. We went ahead and said, okay, where exactly does the sample land on this distribution? And we found that it's -3. .006. So let me sketch that. Remember, on this number line, the center is 0. This number that I marked in red is -1.7. And now let me mark -3. -3 is way over here on the number line. And I hope that you get to see what this essentially tells you. And again, it's 3 essentially standard deviations to the left. Because it's a t distribution, we know that values that are far away are more likely, so we got to be careful. You do need to find the critical value. So again, just visually, this makes sense. According to my visual, my sample is unusual. Our sample data is unusual for the distribution, the given distribution. And that's exactly why you always want to draw the distribution. And for earlier stuff, I always drew the distribution. Part of it was because it was supposed to prepare you for this. And now that we see that my sample isn't quite in agreement with what Starbucks was saying you would get a sample here. We finally are able to answer the question. What is your conclusion? Is the sample evidence for or against the claim? So the claim, we're talking about the Starbucks claim. So think about this. Do we agree with Starbucks? No. So what we're going to say is we're going to reject age 0. My sample rejects age 0 because it landed exactly where I told you it was going to land, because I was telling you the entire time that, hey, they're underfilling my drinks. The true mean is actually less than 16. So check that out. My sample is actually in that tail that I drew ahead of time. So all of this drawing you do ahead of time before you do before you take a sample. Okay, so because you reject age 0, you're now going to say, see, I told you I was correct. So our sample provides evidence that we are correct. All of this is evidence. Your sample is the essential evidence for the claim. All right, this is essentially a hypothesis test. Let's go ahead and summarize what just happened. So hypothesis testing is essentially a procedure. Think of it like writing an essay. In an essay, you want to make sure that you follow certain structure. So the procedure just basically is here to ensure that we follow the structure, the logical structure. To essentially test this hypothesis. All right. So what we did is you're always going to be able to write the hypothesis. The parameter. So again, this is either mu, p, or sigma. There is some claim as to what that value should be. Then we think that, right, we believe that something's off about the claim. So then based on our sample, and the sample always is given. So if you have the sample with data, if you have the sample, sorry, like we did previously, you would use with data. And if you only have the results, then that would be a summary. And finally, you go ahead and you test, you reach a conclusion. All of the work that we have here is essentially what we're going to keep doing for the rest of the class. So please make sure that this makes sense. If there's any questions, check out the next video where we will go ahead and focus on step number 1 and 2, writing the hypothesis. All right, so check out the next video so that you can learn how to write the hypothesis.